Hello my friends, my name is Adrian. We are going to talk about a very important and I think quite overlooked AI topic, which is vector databases, and something related to that, which is RAG. So this is not about food, this is just to show the parts of the presentation. I'm going to try to explain this in a way that everybody can understand it, even people that are completely new to AI. So first we're going to talk about vector databases as a light but necessary start, and then we'll switch over to RAG as the main part or the main course of the presentation. And then in the end, we'll do a quick visit to search engines or vector search. So vector databases are used for artificial intelligence and search engines. They are used by existing pre-trained foundational models. Of course, we don't have access to the vector databases used by these models, but if a company has its own internal vector database, to do something useful with it, it's going to need a RAG. So later on, we're going to see really how a RAG works. So a few years even before the flourishing of generative AI, of course, artificial intelligence already existed, and it was quite good for some things, even before the years of the pandemics. AI was good for things like image recognition, recommendation algorithms, weather prediction and simulation. It could forecast where a tornado was going. And even before this Gen AI bubble, you had text prediction algorithms, but without semantics. But all that AI was quite good. It was done partially using complex hard-coded set of rules and partially machine learning frameworks, with a portion of machine learning increasing over time over the hard-coded rules. But now with vector database and generative AI, the machine understands semantics. And this opens very powerful new ways of creating machine learning frameworks or strategies. So this is how an oversimplified table of a vector database looks like. A vector is a list of numbers. So each of these numbers is really a dimension, which is actually a distance between one item and another in a given aspect. So a dimension between these objects can be anything you can think about it to compare two objects. For example, the complexity of an object, the portability of it, the usage of it. Is it more related to the security industry than another item, for example? So the dimensions allow the machine to effectively compare objects. And if you really think about it, our thought process is not so different. Because when we think about something, a word, an idea, we get the meaning of that word by the relationship it has to another word or object. And one last thing. So this is an oversimplified example because in real-world databases, each item has hundreds, if not thousands, of dimensions. And in this case, we just see 6 for every item. So you would need a really specialized vector database like Weaviate, like Pinecone. If you are already using a good relational database that works for you, if you have, for example, PostgreSQL, like it might not be ideal for a vector database, but in the case of PostgreSQL, there are new specialized extensions for vector search, where you can add vector search to your SQL queries and have some kind of hybrid functionalities. So probably you should check that if you are using PostgreSQL and want to do some vector search. Why is RAG and vector database something we should really care about? Think of this as an internal vector database with tons of scientific content. For example, the discovery procedures or the discovery knowledge or scientific knowledge of a company that does scientific research wants to keep all that information private and secure. So you don't want your external LLM provider to have access to this privately owned information. However, you still want to do prompts and questions and get answers from the LLM based on your latest up-to-date internal information. So how do you solve this riddle? The answer is RAG. This is why RAG coupled with vector databases has become an increasingly common pattern in companies that are incorporating AI. But not only for chatbots, also to run semantic searches against your private vector database. So, just in case this is not a fight between a table and a desk, this is just to compare these objects and get some dimensions out of it. So we can make a nice looking multi-dimensional graph. An example of a dimension where they would be pretty close is the first thing that comes to my mind is eating, because you can eat both in a table and a desk, although eating in a table is probably a bit more convenient. But in this dimension that would be pretty much close. For example, what about cracking a coconut? A poorly trained LLM will think coconut is food, so food is related to table and desk would be unrelated. And it would set a huge distance between these two objects in this dimension. The reasoning of a better trained LLM would be for the purpose of cracking a coconut, a table and a desk is exactly the same thing. And it will set the two objects in the same point in this dimension. So before the training data, there would be probably a big gap, a big distance between the two objects. But then if we are going to feed a lot of text into the training model, it's going to understand they are pretty much the same thing, exactly the same thing for the purpose of cracking the coconut, and is going to fix that, is going to put it in the same point. Now let's think about a new dimension, writing a poem. Okay, the same thing is going to be almost the same thing to the poem in table or in a desk, but probably a bit better in a desk. So these nuances between ideas is semantics, and the more dimension an object has in a vector database, the more context you have in your semantics. So the LLM is going to be able to do a better work with it. Now let's get into something more realistic. We're going to see a 4-dimension graph using words and ideas from the oil industry. So all these words and ideas, after they are compiled into raw text and vectorized, they are going to form clusters of words which contain closely related ideas. For example, energy could be a cluster of closely related ideas. Oil producer could be another cluster. And then we're going to see how they are represented into a 4-dimension graph. So here's the graph. Similar ideas belong to a same cluster. And if I add something that is somehow related to two clusters, for example, oil producer and electricity or energy, which is another cluster. For example, if I think about something used to transfer oil into energy, like oil refinery, it's probably going to show up between both clusters. And here we also have violations, discouraged. So sounds more like a legal concept. And if I say penalty or fine or economic sanction, this is probably going to show up somewhere between both words, violations and discouraged. So now we are going to talk about RAG. So before you do the RAG, you're going to grab all your data, whether it's PDF articles or documents or HTML files from internal websites, or now companies have Confluence articles. You're going to grab all those files and compile them into raw text, then slice them into chunks and do a vectorization. So you're going to need some tools for it to automate all the chunking and embedding, and you can use Python dependencies for that, especially for chunking tools. And you can have open source embedding models. You can find them in Hugging Face, or also closed source like Google embedding models. And then you're going to put vectors into each of these chunks. So all the stuff in the vector database will be already chunked and vectorized before you can do the RAG. And the RAG under the hood is going to feed the LLM with a selection of chunks retrieved from the vector database. These chunks have to fit into the context window of the LLM. So what is RAG? Again, it's something that allow us to get a result from an LLM or search engine grounded in our private information while keeping the data private and secure. How exactly it works, we're going to see that in the next slide. So first, when you have your RAG and your vector database set up, you're going to do a prompt or a question. This prompt or question is going to be vectorized. This means converted into vectors using the same embedding models we used for our vector database to have, let's say, the same protocol, so to speak, so you can compare the question with the vector database. This comparison, you can also call it semantic search. And the vectorized prompt or question can be used to do a semantic search or query against your vector database. So all that information must be already chunked beforehand in the vector database, so our semantic search can return a selection of the top most relevant chunks. Then it reformats the initial question or prompt by incorporating the chunks into it to provide context based on our vector database to our LLM. So the result of that is an answer from the LLM with all the context it didn't have before, using our internal and up-to-date context from our vector database. So this is the same slide here, but all the flow of the RAG is really well described in a little nice text box. Now a few words on chunking strategies. For example, if you want to do some historical reasoning about the guillotine, which was a chunking tool, but providing your own context extracted from a privately owned history book, before you feed your vector database with your own history book, you're going to need a good chunking strategy. You're probably going to need big chunks and small chunks. Big chunks are rich in context, but have a lot of unrelated content. So it's going to waste tokens. Small chunks may lack of content, but are precise and token efficient. So for something both efficient, precise, but with a good historical context, you would need to retrieve big and probably also middle-sized and small relevant chunks. Of course, if your context window allows it. But let's not forget that the latest LLMs have a much bigger window size than the older models. So, for example, you are going to want to have the relevant part of the fall of the monarchy. Of course, not the whole French Revolution. That would be too big with a lot of unrelated content. You're going to want to have a middle-sized chunk, like it would be the whole episode of the behead of the King Louis XVI, and maybe also a small but more concise chunk would be how the guillotine as a chunking tool was invented, created, and tested. So as you can see, all those chunks are probably going to be overlapping with each other. Now we are going to talk about search engines. So before the Gen AI bubble, Google had some algorithms to define which website had to be deserved to be in the best position in the Google search, but it didn't have all that stuff was very good. There was a machine learning component, but it was not vectorized. So it had to send crawlers or spiders into the websites indexed in the Google search, and then it had some algorithms to decide which information was the most qualitative. And as part of my past experience in the time of pandemics as a web developer, I did some search engine optimization to improve website rankings in the Google organic search. And I had to add, as a web developer, a lot of descriptions everywhere in the website. Product description, metadata, tags, image name, image description, a lot of HTML text. And I had to provide lots and lots of context. for the spiders to understand what the website was real about, and to qualify it as a website that deserved a good ranking in the Google organic search. You needed also to add backlinks referencing your website by another websites with good rankings. So to get a well-referenced website in the search engine, you needed to do a very good website with quality content, good user experience, and with real organic traffic. You could not trick the algorithm, you could not cheat, otherwise the algorithm would find it and you would lose your ranking. And this is not, this was working really well, but now all that information in Google is vectorized, so it works way better than before. This leads us to hybrid search. So what is that? So for example, in your company, you want to do some semantic search in your vector database, but you want only the chunks of your vector database where a specific given email address is part of the chunk. So for example, only the parts of the vector database or the pieces of it, whereas an email address of compliance or a regulatory email address. So for example, compliance@yourcompany.com. So an email to report policy violations, for example. So you need exact match in combination to the vector search. This is a hybrid search. Another example of hybrid search would be you submit, doing the search, you submit an image of a dog in a boat, and it will return to you another image of a dog in a boat. So this is an image-to-image search with metadata, or you can do the same kind of query, but you can ask for a cat instead of a dog, and you will get a cat in a boat. So we are reaching the final part. We're going to talk about some privacy and ownership concerns. I think there are concerns. When we use LLM models, we're not directly training the model that is in production, but all the data we provide when doing prompts, questions, when providing context, is sent to another model that is still in development. And I think there can be some privacy or ownership links, breaches, I'm sorry. So with this note of concern, I think we should think about, we're going to close this presentation, and thank you for your attention.